Start recording. Okay, so now we already discussed about type 2 and type 3, right, which is for L2 EVPN. But there are type 1 and type 4 as well, which is also for L2 EVPN, right? But type 1 and 4 is not useful, or it's not needed if you have MLAG pack, leaf or MLAG, right? But if your leaf is not MLAG, right, then you need type 1 and type 4, right? Type 1 and type 4 is required. Okay, so let's understand why, right? Why we need type 1 and 4, and what type 1 solves, basically what is it use, right? Why we need this type 1. So one is fast convergence, mass withdrawal, right? So we'll discuss this, that what does this mean, right? Fast convergence, mass withdrawal of routes by VTAP, and aliasing, right? Load balancing across multiple egress points, right? So these are the two main reason why, right? Why we need type 1 route. It is also called auto discovery route. Okay, auto discovery route for Ethernet segment identifier. We'll discuss what is this Ethernet segment identifier. Okay, only advertise if ESI is non-equal to 0. Basically, I'll discuss this, right? Whatever, in which case this type 1 is advertised, right? Not used in a multi-homing. This is not required, right? With Arista devices, both are Arista devices, then we will have MLAG, right? So this is not needed. Okay. But if you don't have MLAG, right? This is the host which is dual connected with both your switches, right? But both are different vendor or it's non-Arista, then you need multi-homing. Basically, then you need this type 1. Okay. So let's look at the next slide where we'll discuss about this. What is first of all Ethernet segment identifier, right? So let's understand that you have this customer A, okay, customer A, which is connected to two VTAPs. Either we can consider it as a PE, or as we know more familiar with VTAP, let's consider these are two VTAPs, right? Two VTAPs. So for redundancy purpose, your client host is connected to two VTAP, VTAP 1 and 2. But both are non-Arista, or let's say one is non-Arista. You don't have MLAG possible, right? MLAG is not there. Now what you want to make is this, you want to keep this as active, right? Active link. Both are active link, active. Now, first challenge is to bring this port channel up, right? LACP, with LACP, correct? Because both are different devices, switches, right? So what will be the problem here to bring port channel up? Anyone?
System ID.
Yes, system ID will be different, right? So because system ID at both sides, what client A will or host will receive, it's different. It will not bring up, or will bring up only one port channel, right? One member, but not with both the members. So what can we do? What is the solution, right? How we are solving this with MLAG?
Making the configuring the system ID manually.
Yeah, so okay, yes, so that we can solve this by configuring system ID manually, right? In MLAG, what as you remember, they take only one system ID, right? They basically primary and secondary, and they take only one system ID or MAC address as a system ID and send that, right, in MLAG. So that is automated. But here we have to configure system ID, right? So basically, if you configure port channel, right, interface port channel 10, this on switches, this is what your configuration is, right? Only this much with MLAG. But if you are configure using this type, right, without MLAG, then you need to add this further configuration, right? So you have to go to EVPN Ethernet segment. You have to configure identifier, route target, I will discuss, and also LSSP system ID, which is this, right? So basically here you are configuring this, and same here, right? So basically you are saying for port channel 10, right, which is this down here, you use LSCP system ID as this, right? What is configured. Okay, not the one system MAC address, but this system ID, which is common configured for both. So now what they will do is both will send LACP PDU with system ID same, right? And for this host, it understand that, hey, at this LACP PDUs I am receiving from one switch, right? It's same system ID. So it will bring this up port channel. Correct? Any question on this? Is it clear why we need same system ID, LACP system ID?
Yes.
Yeah.
Okay, perfect. Now next is another thing is Ethernet segment identifier. Okay, this value. So Ethernet segment identifier is nothing but a number, right? Which is, it's a 10 octet integer, right? Number. This first T, right? That starts, it's a type different. There are different types of ESI, Ethernet segment identifier, different types. What we use is 00, right? So first two octet we will have is 00. There is 00, 01, 02. But in our case, we'll use type, right? That is this 0 type 0, which has first two octet as 00, right? For first octet. And after that, all octet you can choose anything. So basically just make sure whenever you type Ethernet segment identifier, write 00, and after that it should be anything. Now basically what is purpose of this, right? So let's say this is basically you will configure this Ethernet segment identifier, which should be unique, right? Which should be unique, right? On both these devices, VTAP devices, right? Now what will happen? Let's say client A wants to send packet to some host behind this VTAP, okay, VTAP 3. Just consider P as VTAP. So this is VTAP 1, VTAP 2, and VTAP 3, right? This guy wants to communicate to this guy here, okay? Let's say C, okay? Now, because this is MLEC port channel, right? It will send packet out to any of this link, right? Let's say it's sending out packet here, right? So your MAC is learned here, right? Say MAC A, right? MAC A is learned here locally, ET1, correct? ET1, right? Will you learn MAC here on P2 when customer client sends first packet?
No, it should
No, right?
be.
Because
Yeah.
MAC has learned, come here. You don't have MLEC between these two who can sync the MAC, right? So basically you learn the MAC and ARP here, okay? Okay, but you don't learn here. Now, what you will do is you create type 2 route, right? Type 2 route, right? For MAC, and advertise it to the all the VTAPs. So you advertise it to both the VTAPs, right? Now this guy learned the MAC, right? This guy learned the MAC VTAP 3 that, hey, MAC A is behind which VTAP? VTAP 1, right? Is it clear?
Mhm.
Okay. But if you see, right, if the C has to send the packet, right, actually, how many options it should have? Means, should
Two.
I two, right? It can send packet to VTAP 1 and VTAP 2 both, right? Because both are connected to this A, correct? So actual, if you see, the path should be both, right? Load balance, right? But with this case, it will be only what VTAP 1, right? Because this guy has not learned MAC, right? So what we can do? So that's why this Ethernet segment identifier and basically auto discovery comes into place, type 1 route. So what this guy does, PE1 does, it will send type 2 route, but it also sends type 1 route, okay? Type 1 route. So as soon as you configure this, right? As soon as you configure this into your switch VTAP, it generates type 1 route, okay, and send it to all the VTAPs. Now what information will be there in type 1 route? it will say that, hey, I am part of Ethernet segment identifier, right? ESI, right? So basically I am common, I belong to this Ethernet segment belongs to me, right? And then also it will send out other information. Let me show you first what are the information, right? It sends packet format. Yeah. So it sends Ethernet. Route distinguisher, right? RD value. What is we have configured on VXLAN EVPN. Ethernet segment identifier, right? That ESI value, right? This ESI value which we have configured, right? On common segment. Ethernet tag ID, right? Ethernet tag. VPN or MPLS or VNI label. What is VNI, right? VNI label. And extended community tunnel encapsulation, whether it's a VXLAN or MPLS, right? What will be the data plane? Extended community ESI label, right? Ethernet segment identifier, basically ESI value, and then route target. That is the EVPN route target, right? So these are the information will be sent. So basically it will send that all the information, right? So this guy will send that information type 1 route, right? Basically now this guy know, okay, type 1 route. So this guy has sent type 1 route. It has already sent type 2 route, right? Type 2 route is also sent for that MAC. And from based on type 2 route, it has populated that, hey, for A, it is behind VTEP 1. Now this sends type 1 route. P2 also sends the type 2 1 route. Okay. As soon as you configure all this and also under BGP, EVPN, VLAN based configuration, right? RDRT. As soon as you configure this thing, P2 also sends out type 1, right? Type 1 route. What it says is, hey, I am also part of this Ethernet segment, right? If you have any packet for this Ethernet segment, you can send it to me because I am also part of this. So what will happen? P3 will receive, obviously this MAC is learned through type 2, but it also understand that, hey, if I have to send any packet to this Ethernet segment, right? I have two paths, right? So for particular ESIA, let's say this is ESIA, right? So for ESIA, right, I have two paths, two VTEPs, VTEP 1 and VTEP 2, correct? And if you remember type 2 update, we also have Ethernet segment identifier field, ESI field, right? So basically in this also you are saying, hey, I am part of this Ethernet segment and this is my MAC and it is behind VTEP 1. This is type 2, right? ESIA, right? You get another information that, hey, ESIA is common to VTEP 1 and 2. So if you combine both of this information, what you will get finally is that to reach MAC A, right, you have two paths, VTEP 1 and VTEP 2. So you will, this PE3 or VTEP 3 can load share. Is it clear? Any question? Is this clear?
Vishal, so the identifier is should be unique, right? What if there is another CB providing the same identifier?
Correct. Yeah, that's good question. That's right. You are right. Absolutely right. So let's say there is customer B, right? Another host, which is also connected to both the PE1 and PE2. So basically you have to make sure this Ethernet segment identifier ESI should be unique for each port channel, right? So this is, let's say, port channel 10, right? Now you configure another port channel 20. So it should be unique. Even it's not unique between these two. Let's say there you have another two PE device, right? PE4, 5, correct? And there is one host connected there. So basically Ethernet segment identifier, what you use on this VTAPs, right? That also should be not used anywhere, right? Otherwise it will create problem, correct? So you need to have Ethernet segment identifier unique across your setup, right? Only for that particular port channel or host. Okay. And yeah, and it should be same, right? On this, both of this. So this config should be same for on both the VTAPs, right? So that this is shared. Okay. But yeah, that is correct. Any other question or anything, Raja, any further?
So only the P's should be configured, Vishal. So nothing.
Yes. VTAPs should be configured. P or VTAP means consider it as P as VTAP, then VTAP
Okay.
should be. Yeah.
Thanks.
Okay. Okay. Any other question?
Vishal, so in case this CA sends our request broadcast basically to PE1, so this will be sent to the route reflector spine.
1 minute. Are you talking about MAC or ARP?
Any broadcast, any bump traffic basically.
Okay, broadcast traffic. Okay.
Yeah.
So customer is sending bump traffic, right? Flood ARP request. Let's say ARP request. Yes.
Yeah.
For which it's sending ARP request for which host?
Suppose PE3 or any host behind PE3 basically.
Okay. Same VLAN or different VLAN?
Same VLAN.
Same VLAN. Okay. So it's same VLAN 1010, right? Okay. Perfect.
Now this will reach core, right? From PE1.
Yeah, it will reach. Okay. So first of all, whether this ARP, right? This ARP. So I understood that host A wants to communicate to this host 3 or C, right?
Yeah.
C.
Yeah.
Now, tell me, host C has already communicated to anyone else, or basically my point is whether ARP of host 3 is already learned?
No.
Okay, perfect.
New setup.
So new setup, fine. So now what will happen that this VTAP will check that, hey, this is ARP request, right? I have to flood it to all the VTAPs, right? So it will create, it has type 3 route already populated as soon as you configure, right?
Yes.
EVPN
Yes.
and all that. So he knows what are the other VTAPs available, right? VTAP 2 and VTAP 3, both.
3. Yes.
Both, right? Now in this case, this VTAP should be different VTAP IP. I mean, this is say 1111, then this should be 222, right?
222.
Yeah, because this is not MLAC. Okay. Okay. Yeah, go ahead now.
So in MLAG, we basically provide have the same VTAP. I agree. So when the route reaches the core, it is not sent back to the MLAG pair.
Yeah, right? In MLAG, yeah, it is there. Correct.
So now over here, it will be sent back to PE2 and PE3.
Correct.
The orbits.
Yes.
Right.
And then, yes. And you decapsulate. Yeah, go ahead. Go ahead.
So now it will be de-encapsulated. PE2 will drop it, and PE3 will basically send it out. But if this was unicast flood, right? So PE2 will see that, will also broadcast it back to C the host.
Correct.
So wouldn't that be a loop?
Yes. You are right. We'll come. So that's what we will use type 4. So that is the purpose of type 4, where even this ARP request also what PE2 has to do, right? See, even this, we talk about ARP request, as soon as it receives the ARP request, what it has to do is it has to decapsulate the packet and then flood, right? Then ARP packet also can go here, right? That can also go here, right?
Yeah, but CA will drop it because
CA will drop, but PE2 will do it.
Yeah.
Right. So basically, point is it's all bump traffic will go here, right?
Yes.
Which is not needed. It's unnecessary. In fact, let me tell you one more scenario as we are discussing this, right? Let's say PE3 behind PE3 wants to communicate with this A, right? What it will send? It will send ARP request. Now this guy will send ARP request to both the VTAPs. right?
Uh-huh.
Correct? Encapsulate and send. Both will decapsulate and send here, right?
Hmm.
What happens?
But
Unnecessary. Yeah.
shouldn't it choose only one VTEP basically to send out the broadcast?
No, both, because your VTAP are different. No, this is
Okay.
1111 and this
Yeah.
is 2222.
Yeah.
So your flood list, this guy has flood list 111 and 222. It will send
Hmm.
to both, right?
But if so, on the PE3, basically it should have that ESI is reachable by both these VTEPs, right?
Correct. But that this is yes. So that, but still app request, it will not see ESI when it comes into place. ESI plus type 2 will make your reachability for Mac A to through VTAP 1 and 2, right? But what right now we are assuming is this is new setup and this Mac is not learned. This A is not learned at all, right?
Okay, good. New
Now you have to
setup.
send out app requests. So what you have to do? You have to flood to all the VTAPs, right? You don't know where this Mac is. So you
Yes.
will send to both. Both will decapsulate and send to host A. So unnecessary host is getting duplicate packets, right?
Yeah.
So how to solve this? So we'll discuss this in type 4, right?
Okay.
That's why we have type 4 that we'll discuss. But yeah, this is good point that there will be this type of issue will be there, right? And we have to solve this.
Yeah.
So whenever you don't have AMLAG, right, we have this type of issues and we have to solve that. And that's why we need type 1 and type 4. So one problem we are solving with type 1 is common system ID, right? So that you can bring up port channel. Another problem we are solving is same system as the ESI, Ethernet segment identifier, so that you can load balance, right? Load balance, auto discovery, right? Basically PE3 will discover, no, sorry, 1 minute. It was, what was that? Aliasing, sorry, this is called aliasing. We'll discuss more. Auto discovery is type 4. We'll look into it. We'll discuss that. What is auto discovery? Type 1 is aliasing. So basically PE3 will alias or load balance, because now it knows that to send packet to Mac A, I have two paths, right? VTAP 1 and 2. Okay. Okay. So this is another problem we are solving, right, by using this. Now if you see here, there is one more configuration. We are configuring route target even here. So basically under under BGP VLAN 10, right, and then we configure RD and RT, which is already there. It is there. It's a different, this RT, let's say 10:10 is different. Okay. But we also configure this route target import here under port channel. Okay. So this is another configuration where you configure this route target. Okay. And we will see what is the use case of this. This is used for type 4 route. Okay. Type 4 will be used by type 4 purpose of this. Okay. That we'll discuss. One more point I want to bring is that if this your host B is single home, right, it is only connected to one VTAP, then you don't have to configure all this, right? Because it's a single home, right? So in that case, when as soon as you learn this MAC, right, you will send out type 2 route, type 2 route, type 2 route, right? Only type 2. Type 1 will not be sent for this because you don't have Ethernet segment identifier for this guy, right? So ESI or type 1 will be advertised only when you have this and without MLAC, right? In that case only you will send out type 1 update, right? Both of this will send out type 1 update. Is it clear? Any question? What is ESI, right? Why we need system LSCP ID same? Why we need Ethernet segment identifier? Okay. Any question on this?
Sure. It's clear for me. I have a question. It's not completely related. You remember how we spoke about like the virtual VTAP IP?
Yes, VTAP IP.
When we get some frames coming from the device A that's multi-homed, we're going to use the virtual VTAP IP, or How
Okay,
would it work?
so yeah, so with EVPN, right, in this case, basically you don't need to configure VVTAP IP. The reason is
Okay.
because now there is no ARP flood and all that stuff, right? ARP reply. Basically, you don't have to sync ARP sync. See, VVTAP, there are multiple reasons for, right? That was that unnecessary. You are basically, when you send out ARP request for this particular, host, right?
Mhm.
This guy has to reply back with means all the VTAP will reply back with its own IP address. Okay, so let me clear out and give it
Okay,
again.
I think I get you. Like, there's no need for it. Like, we have type 2 BGP to take care of the ARP,
Yes, yes,
so we don't need it. Okay, makes sense. Yeah. So
yes,
in
yes.
EVPN, we shouldn't really need to configure the virtual
VTAP,
VTAP. Okay.
yes. At
Thanks.
least
Appreciate it.
asymmetry. We'll come to that, means in which scenario. But yeah, right
Mhm.
now what we discussed, that's not needed.
Okay. Okay. Thanks.
Okay. Yeah. Okay, so now let's move to next one, that is to understand more. So basically there are some rules, right, for Ethernet segment configuration. So basically each locally configured Ethernet segment must provide RT that enables all PEs connected to same. So basically you need to configure route target, right? We'll discuss that why, but yeah, we need to have, and that should be same RT. Yeah. All PEs connected to Ethernet segment must have identical MAC-WAF config. So this is nothing but this both, right? This both VTAP should have identical MAC-WAF, right? VLAN WAF configuration. Under BGP, we configure MAC-WAF, right? VLAN 10, RD 1:1 or 2:2, and route target 100 or 200, right? So that should be same. That this is nothing but same as what we configuration should be same even for MLAC pair, right? So that should be same between these two VTAP devices. Okay. So that should be same. We should have same LSCP system ID. Yeah, we discussed, right? Why we need to have same LSCP system ID. And this designated forwarder, we'll discuss this when we discuss about type 4 route, right? So basically why designated forwarder is needed and what is the use case of it, that we'll discuss for with type 4. Okay. So basically this is common rule. You need to have RT configured, system ID, LSCP system ID should be same, and MAC-WAF configuration also should be same. Okay. FDDF we will discuss next when we discuss type 4. So now this is aliasing feature which we already discussed. Let's go over it. So it's same. See, okay. So let's discuss this out, right? You have server 1, which is connected multi-home to both the VTAPs, VTAP 1 and 2, right? There is one more server here, which is connected to VTAP 3 locally. Okay. Now, as soon as this guy sends traffic, right? Any traffic, you learn the MAC locally, right? You learn the MAC locally on one VTAP, right? You learn only on one VTAP. You advertise this type 2 route, right? Type 2 route as soon as you learn the MAC address. Okay. And here you learn that, hey, MAC of server 1 is behind VTAP 1. Okay. VTAP 1. Okay. Now, as soon as you have also configured port channel with Ethernet segment identifier, right? And LSCP system ID, and also you have configured under BGP VLAN base MAC-WAF EVI, right? So as soon as you have configured that, you also send out this type 1 update, right? Type 1 update. What is the information in that? Hey, I have Ethernet segment identifier A common, right? This ESI is with me, right? And that information will be sent to this guy. So basically it knows that VTAP 3 knows Ethernet segment identifier A, ESI A, this segment is behind VTAP 1, right? VTAP 1. Similarly, this VTAP 2 will also send type 1 update, right? That, hey, I have Ethernet segment A connected to me. So it will update this here that, hey, you can reach Ethernet segment A via two paths, 1 and 2, both VTAP. Okay. Now, if you combine both of this information, what does it mean? If you can, because 1 is also part of Ethernet segment A, right? You also type 2 also carry Ethernet segment identifier, right? So basically you will, based on this information, you will update the table that, hey, to reach MAC 1, which is behind Ethernet segment A, you have two paths, VTAP 1 and VTAP 2. Right? Basically, all the MAC addresses, all the MAC behind Ethernet segment A, there can be 100 servers here, right? In between there is L2 switch, and there can be 100 servers here. All servers are reachable via Ethernet segment A, right? So basically, for all the MAC, you can say that, hey, it is reachable via both the VTAPs 1 and 2. So this is called aliasing feature, right? Load balancing feature. VTAP 3 will able to load balance traffic to both VTAP 1 and 2 because of this type 1 update. Is it clear? Any question?
So the type 1 update, right? Is it sent each time? Okay, so it must be sent as soon as we configure it, right?
Yes. So let me show you guys that, right? I have lab. Okay. So let's say this is PE11, right? VTAP 1, and there is another VTAP pair of this PE12. Okay. And this is a other side, PE3 type, like other side VTAP. Okay. And this is client 1, which is multi-home to PE11 and 12. Okay. Let me open PE11, that also. Right. So we have, yeah. Okay, so this is P11 and 12, right? And show LLDP neighbors, right? Client 1. See, this is the client 1, right? This is client 1. So client 1 is connected to ET3, okay? And here also show LLDP neighbors, okay? So client 1 is, where is client 1? MS0, DFD2, okay. It's not multi-home. Okay, anyway, let's look into this. Okay, let's say consider if config. Okay, so basically the MAC address DFD2 we have learned here. Okay, DFD2. Show run interface ET3. Okay, ET3, it's port channel group 3, right? Show port channel 3. So it has only ET3 port, okay, this port. Okay, perfect. So now let me show you the configuration. Show run interface port channel 3 config, right? So port channel 3 configuration, if you see here, right? 1 minute, let's see here. Show run interface port channel 3. No, that's not the port. Yes. So maybe I think this might have gone wrong somewhere here. ET3 is down. That's why. Why it's down. Okay. Fine. So basically ET3 is also connected. It's not reflecting in LLDP. Maybe there are no communication, but ET3, both ET3 is connected to same client, right? So if you see, that's why port channel config is same, right? So port channel configuration is ESI identifier is same, import route target is same, right? And system ID is same, correct? So that port channel will come up, right? Now, as soon as we have this config and also the another config, BGP, right? This is the configuration, which is our normal config, right? Not special for multi-home. Multi-home spatial is only this much, right? This thing, okay? Now, as soon as we configure this, right? We configure this, even we have not sent any traffic, right? If you see, we have not sent any traffic from this host, okay? MAC is not learned. This MAC is not learned here. We have not sent any traffic, but still, if you see here, show BGP EVPN, right? Route type. I want to check only specific route type 1, right? Which is nothing but auto discovery. So auto discovery, and let's say a detail, right? So what it's doing is, as soon as you configured above, you are sending this auto discovery. See, this is Ethernet segment identifier, ESI, right? 0030, this one, right? So you are sending that information, Ethernet segment identifier, route distinguisher, RD value, right? Which you have configured under BGP, VLAN 100, this, right? This thing. So you send RD value, extended community, route target. This is again your configuration of this RT, okay? This RT route target, not the one this, not this route target for type 1 update, yeah, right? So you are sending that route target, encapsulation, tunnel, VXLAN, and VNI label. Okay. So this is the information you are sending out to other peer to understand that, hey, I am the part of Ethernet segment identifier, common segment, right? I belongs to this common segment. Okay. So that's how this guy sends. And if you check here also, right? So BGP EVPN route type, auto discovery, detail. This would have also sent the same information, right? That I am part of this Ethernet segment identifier, right? So that's what happens. See, both are sending type 1 routes, and P3 already knows that, hey, this two belongs to same Ethernet segment. Okay, both these routes are received on P3, right? So if you go here, show BGP EVPN route type, auto discovery, detail, right? So this guy has already learned this route. See, this Ethernet segment identifier, it has learned through 254.3, right? And the other VTAP is which one? 254.4, right? 254.4 also it would have received this. Yes, 6 maybe, right? So basically it will receive from both of them. Okay. But right now that MAC is not learned. Let's ping and make this MAC learn. If config ping sudo ping and 1, what is here? Yeah, so let's see here MAC is learned or not, right? Show MAC address, show MAC address table. So it has now learned this MAC address, right? DFD2, correct? Show MAC address table, DFD2. See, if you see here the difference from where it has learned DFD2 from VX1, right? From this VTAP, it has not directly learned. Okay, I think that can be because right now this link is port channel is down. Basically show port channel 3, right? Which is LACP race. It's not up. That's why it's showing this. Otherwise, it should show the same as this. But let's, and yeah, that's why over here also we will see only it's learned only with this guy, one guy. .254.3. But yeah, the point is, as soon as you send out type 1 update, it will as soon as you configure, it will send out type 1 update, and this guy will now know that I have load balance, right? I can load balance this too.
Understood. Yeah.
Okay. Okay, so let's move to next slide. So this is analyzing.
Sorry, Vishal.
Yeah, go
I
ahead.
think I missed out on the P3 output from
Oh
the
yeah,
CLI.
yeah. So
Uh,
P3. So right now, because see, the problem is this link is down, ET3. So this is not right now. This client is connected only to this guy, P1. P2
okay.
is down. That's why we are not able to see the intended load balancing.
So I was just curious. So in case the other P was also sending, which output? How do we see the two of them reflecting? In which table are we seeing the load balancing?
Okay, yes. It should be this. See,
Or should show
591A,
something?
right? 591A. See, this is showing both the paths, right? So
Okay,
let's
okay.
find out where is 591A, right? It should be client 2. What was this? 591A. Yes, this one. See, 591A, right? So 591A, this guy is also connected to this, both of this, right? Let's ping. I think Mac also is long. Yes, so let's take this example, right? So that we understand that. So 591A, right? This client, host 2, is also connected dual home to both of this, okay? And you can see here that 591A is configured to port channel 4, right? Connected to port channel 4, right?
Yeah.
And here also port channel 4. So basically this is connected to both of this, right? And they would have advertised show PGP, EVPN, route type, MAC address, MAC IP detail, right? So they would have advertised this type 2 route, correct? It has advertised type 2 route that, hey, you can reach type 2 route, basically not this, where is local? 591A, right? It is 591A, DFD2.
Yeah.
No, it's a DFD2, correct? 1
No,
minute.
it's 591A.
591A, yeah. So this 591A, right? It has advertised this locally, correct? Type 2 route. As soon as it has learned the MAC, right? Similarly, VTEP 1 would have also. And then if you go here, right? Auto discovery, it would have also advertised type 1 route that, hey, I am part of common Ethernet segment. This is the Ethernet segment for this guy. Okay, 4.4. So basically at your P3, right here, you receive both show BGP EVPN route type, auto discovery. Let's this much, okay? So basically you learn that is 4.4, right? For port channel 4, it is 4.4. So you can learn that, hey, this type 1 route I have learned through 2 VTEPs, 3 and 4, right? PE1 and PE2.
Yeah.
Right. So now you know that, hey, PE1 and PE2 I am learned, both are part of same Ethernet segment, right? Both are same, belongs to same segment, PE1 and 2. This is PE1 and this is PE2. So both are same Ethernet segment. And you also run EVPN route type MAC IP, right? So you know that, hey, what was that? 591A, right?
Yeah.
So 591A also belongs to 253 and 4. And it also gives you Ethernet segment. Okay, let's run detail. 591A, right? How we learn 591A. 591A, where is it? Yes, this. So 591A, you also say that, hey, this is the Ethernet segment I belongs to, this MAC, right? So basically now you got two information. Type 2 says this MAC is reachable via PE2 and this Ethernet segment it belongs to. Type 2 route will give you that. Type 1 route will give you that, hey, this segment belongs to VTEP 1 and VTEP 2 both. And you will combine that both information. And when you check show MAC address table, right? It will obviously say that, hey, it is VX1, but then when you run VXLAN address table, it shows that it is through both the VTAPs. Okay.
Okay.
So maybe you can just use this lab, right? If you want to check anything further on this.
Yeah, that's good. Thanks.
Yeah. Okay. So let's quickly go through the another one, right? The another problem it is solving, type 1. That is mass withdrawal feature, right? Now let's understand what is that. Let's say there are 100 hosts. Okay. There is in between L2 switch behind this port channel, correct? This port channel, let's say 10. You have 100 hosts. What you will do is you will learn this all the 100 hosts, maybe some here, and you advertise that host. Let's say, basically you have advertised this host type 2 routes, right? To this VTAP, right? Some from here, some from here. But as you have also advertised type 1 route, this guy will know, right? VTAP 3 will know from host 1 to 100, right? We have two paths. One is VTAP 1 and another is VTAP 2. Two paths, right? For all these 100 hosts, because all belongs to same Ethernet segment identifier. Okay. Now, what will happen? Let's say this link goes down. Okay. So basically now VTAP 1 do not have reachability to all the 100 hosts or max, right? 1 to 100 max. It does not have, right? But this guy still understand that, hey, I can send packet to either VTAP 1 and 2, right? And if it sends VTAP 1, there it packet will be dropped because there is no link to this guy now, right? So what is the solution? What should we do?
Withdraw the route for the ESI.
Yeah. So basically, when we learn the MAC, what we do, we send out type 2 NLRI, right? Type 2 NLRI, right? Route update, type 2. So when you lose all this 100 max, right? MAC flushes out here as link goes down. You need to send out withdraw route, right? Type 2 withdraw route for all the 100 hosts, right? Is it correct?
Yeah.
Okay. But what will happen? Let's say this guy sends out. Okay. So originally it started like this. Let me clear. It started like this. First, this link was up. Both link was up. Let's say all 100 hosts learned here. It has sent, all host has sent first packet here to VTAP 1 or is sending packet here on VTAP 1. You learn all the 100 MAC address. You send out type 2 update message, right? That, hey, to reach 1 to 100, you have to send traffic to VTAP 1. Okay. VTAP 1. Okay. Now, you also send out type 1 update, this guy and saying that, hey, we both belongs to same Ethernet segment. So basically now this guy will know VTAP 3 that, hey, to send MAC address 1 to 100, we have two paths, VTAP 1 and VTAP 2. So that's fine, right? Absolutely, everything is perfect. Now this link goes down. This link goes down. Now your MAC flushes out here, right? You send withdraw route, MAC withdraw route. That, hey, withdraw all the route, I am not reachable. Now what will happen? Type 2 route says that, hey, withdraw all this MAC. What will happen? It will just flush this out, remove this, and basically you will also lose this because the originator of type 2 has withdraw that route, right? Correct. So basically, and also the problem is you have to send out lot of 100 MAC address withdraw routes, right? For 100. So that's not scalable, or basically it's not the way proper way, right? So what we do here is we send out, instead of sending 100 type 2 routes or 100 information in type 2 route, we send out type 1 route, withdraw of type 1 route. So basically what this VTAP 1 will do is it will say that, hey, now I am not connected to this Ethernet segment identifier. I am not connected to ESI. Okay. It will also send type 2 withdraw route. It will send, but it will wait for some time, not immediately. Okay. First, what it will do, because otherwise we will lose all the routes. So what first it will do is it will send type 1 route saying that I am not part of Ethernet A segment. So when this guy receives it, it understands that, hey, VTAP 1 is now not part of it, but we still have VTAP 2 because we received type 2 update and withdrawn we have not received. Okay. Now slowly what will happen is this guy, as this link is down, all this host will start sending traffic to VTAP 2. VTAP 2 will develop MAC locally, right? As soon as it develops the MAC locally, it will advertise type 2 route also that, hey, I am connected to this type 2 route, right? So now this guy has VTAP 3 has type 2 route received from this VTAP 2 as well. And after some time, this guy will send withdraw route, type 2 withdraw route to say that, hey, you remove this, I am no longer with it. But because you already received type 2 route and also type 1 withdraw route, your MAC address still will reflect VTAP 2, but not VTAP 1. Okay. So basically this is called mass withdrawal feature. By sending type 1 update message of withdraw, you are saying that, hey, remove all this MAC from me, right? Immediately. So that immediately this guy will remove all the MAC and you will avoid blackhauling, traffic blackhauling. Okay. Is it clear? Any question?
I have one question, Michelle, but it's not really related to this. I like that you showed the lab and the comparison. That helps put things into picture. What did you use for the
Lab?
hosts that do the Linux hosts that do the bonding? Is
Oh,
it like
yeah,
some sort of image?
Yeah. So okay, let me show that. So basically, yeah. So there is a it's a maybe I have to let me show it here only.
Or maybe you can ping me later, whichever's easier. Just
yeah. So it's basically, yeah, it's a host and we have script which will configure, push that config to that. 1 minute.
Yeah, I'm interested in like the image. If I because like in the lab I don't have the, usually I set up like another switch as a host to do the teaming. I don't have a Linux image.
So we have, okay, so AVD, so this is the lab, okay. AVD asymmetric multi-homing, okay. So this is the lab, and in this is the host L3 config. So CD host L3 config, and this is the script, right? So basically it will configure NIC teaming and add IP addresses for all the client hosts. There are floor hosts.
Okay. Thanks.
Okay. So I'll keep this lab also up for today. So if anyone wants to go, use this lab, just feel free, log into this server and go to that lab. Okay. This is see AVD asymmetric multi-home. Okay. And then you have to just log into all the basically this. For you can open this, log into the server. That server you have to log in right on all the window, and then from there you can just log into individual devices. Okay. Just ping me if you need any assistance in this accessing.
Sure.
Okay. So any question? Okay, let